Okay, I hear the recording in progress. So let me share the screen and get started. Okay, so we're on to our last section, 3.6. So we should finish in plenty of time, have a couple of days of reviews. I have my own review questions also, so I'll be just going back through the chapter. And our next exam is this Friday. So you should already know the rules for the exam as usual. So again, exam days, you have to show up on that. I realize for these daily lectures, they're optional. You can always watch the video later, but for the exams, you have to show up for the exams. Okay, and coverage is chapter 3. So you're responsible for this material. This is the homework that you turn in. You must turn in at least 70%, but again, that's pretty easy to do since I do a great percentage of the problems anyway. Okay, so let's continue where we were and hopefully either finish 3.6 or come close to it. Then we have a couple of days for review questions as necessary. Okay, so we're doing complex numbers. Okay, the I business and how do you deal with problems that look like this. Okay, so here we go. Quick reminder from where we were yesterday. If you multiply a complex number with its conjugate, we get a real number. So a plus bi, the complex conjugate is a minus bi. If you multiply it out, you have a squared minus b squared I squared. And then I see I squared is -1. So it's a squared minus b squared times -1. That's a double negative. That gives me a squared plus b squared, which is a real quantity. Okay, so we'll need that from time to time. All right, problem 17, I to the 104th power. Okay, well, 104 happens to follow this pattern. Okay, 4, 8, 12. If you divide 104 by 4, you get 0. So it fits this pattern here. But if you don't recognize that, one way you can analyze that is I to the 104 can be written like this. Because 104 divided by 4, if you punch it in your calculator, it's 26. So it's I to the 4th to the 26th power, right? 4 times 26 is 104. And then I realized, oh, I to the 4th is the same as 1. I to the 4th is 1. So it's like saying 1 to the 26th power, but 1 to any power is just 1. All right, so the answer to number 17 is just 1. Okay. All right, square roots of negatives. Okay, square root of -9. Okay, so the way it works now is you can write this as -1 times 9 underneath the radical. And then the square root of -1 will come outside and become an I. So you have I radical 9. Square root of 9 I know is 3, so it's I times 3, but the normal way to write I times 3 is 3i. Okay, so the final answer is 3i. So whenever you see a negative like that, just take the negative outside. So I comes out, and then the square root of 9 becomes 3. So the answer is just going to be 3i. Okay. So here's a multiplication of complex numbers, number 21. 2 plus the square root of -5, 1 plus the square root of -1, right? So the first thing I'm going to do is anytime you have a square root of a negative, we'll turn it into the I business. Okay, so negative comes outside, becomes an I. See how it just stands up and becomes an I? That comes right out, negative, and then I. So I have 2 plus I radical 5 times 1 plus I. Notice this is considered the standard form of complex numbers, real plus imaginary, real plus imaginary. All right, and we're multiplying these two together. If you multiply them together, you can just FOIL, like normal. First, 2 times 1. Outer, 2 times I. Plus inner, well, 1 times anything is the same thing, so I radical 5. And last, I radical 5 times I is I squared radical 5. And then you realize anytime you see I squared, change it to -1. We had that yesterday. Okay, so for these complex numbers, your answer should never have an I to a power. You should never have an I squared, I cubed, I to the 4th or whatever, because from what we said over here, they can always be broken down further. right? So this is good, has an I, that has an I. This is an I squared, so I change that to -1. Then put it together. We're supposed to put it as a real part and then an imaginary part. So the real means there isn't any I. So in the final analysis, these two here will not have any i's. So 2 minus radical 5, that's the real part. These two have an I, so that's the imaginary part. Factor out the I, and I write the final answer is 2 plus radical 5 I. So that's standard form. There's a real part and an imaginary part. Okay, so 2 minus radical 5 is real, plus 2 plus radical 5 I. And normally you would not punch this in your calculator. We don't care about punching it in the calculator. We'll just leave it in radical form. Okay, square root of 5 is like 2.23 or whatever. We don't really care. Okay, since it's not a calculator course, this is pre-calculus course, right? Not calculator, so to speak. All right, moving right along. 23, square root of -16/9. Okay, so when you have the square root of a negative, immediately make it come outside as an I. So imagine this minus sign, bring it outside, stand it up as an I radical 16/9. So now I just have the square root of 16/9. That's easy. Square root of 16 is 4. Square root of 9 is 3. So I times 4/3. But now that it's I times 4/3, you write it the usual way, where you have number coefficient times the variable, right? Although I is not really a variable, it's a constant, but it's a letter, I should say. So final answer is 4/3 I. And there we go. Okay, so we're just moving along, knocking off all these problems here. And then I see some problems involving division with complex numbers like 25, 27, 29. They do stuff like that, right? So division, 1/1 minus I. This is where you multiply the denominator by its complex conjugate. Okay. Which means on the bottom, I see 1 minus I. I multiply by 1 plus I over 1 plus I. Of course, whatever you do on the bottom, you do the same thing on the top, because this means I'm multiplying by 1. If I multiply by 1, I don't change the value of the expression. So the denominator now looks like a minus b, a plus b, which we know is a squared minus b squared from Algebra 1. Okay, so on top, 1 times anything is just that, so 1 plus I. The bottom is 1 squared, 1, minus I squared. So 1 minus I squared, there's that I squared again, right? So I change I squared to -1. So it's 1 minus a minus 1, 1 plus 1. So it becomes 1 plus I divided by 2. And even though that's sort of the answer, that doesn't fit the proper form. The form is supposed to be A plus BI. Break it up into the real part and imaginary part. So I just divided it into 2 pieces. That means I put 1/2, 1/2, and that's going to be half I. So best final answer is 1/2 plus 1/2 I. And there we go. Okay, 29, similar. So to clean up complex number divided by complex number, you multiply the numerator and the denominator by the complex conjugate of the denominator. So what is the conjugate? Don't even look at the numerator. What's the conjugate of 1 plus 4i? 1 minus 4i. So 1 minus 4i divided by 1 minus 4i. Okay. Now, don't get thrown off by this. You might look at this and say, hey, there's a 1 minus 4i on top. It doesn't matter. It happens to be the same thing, but that's irrelevant. This can be 1 minus 4i, or it could be 27 plus 8 million I. Doesn't matter. Okay. Just faithfully look at this and say, I'm going to multiply by 1 minus 4i. Okay. The fact that it happens to be the same as this, maybe that was just a trick by the author to try to get you to think, second guess yourself, hey, maybe I shouldn't multiply by 1 minus 4i just because I see it over here. No, it's like you go like this, right? And say, no matter what's behind my pen, I'm going to multiply by 1 minus 4i divided by 1 minus 4i. Okay, so you should not get thrown off and say, hey, it happens to be the same thing as this. No, that's irrelevant. Okay, just faithfully do what you got to do anyway, right? Okay, and then you just kind of FOIL out from there. On top, it's a square of a binomial. So that's 1 minus 8i. There's a minus 4i and another minus 4i, so minus 8i. Plus 16i squared. Okay, and we know 16i squared is 16 times -1, so that's -16. So it's like saying 1 minus 8i minus 16. Okay, on the bottom, these are complex conjugates. So it's just going to be a squared minus b squared. 1 squared, 1, minus 16i squared, that's minus 16 times a -1. That's a positive 16. So 1 plus 16 is 17. And let's see what happens on top. This was -16, right? So -16 plus 1, -15 minus 8i. Last step is to just split them into 2. So -15 over 17 minus 8 over 17i. And then that's pretty much about it from there. Okay, so to write the final answer, it's real part and then imaginary part. So if you ever get an answer that looks like this, just split it into 2. Just divide that by 17, divide that by 17. Just like over here, right? Divide by 2, divide by 2. And there we go. All right, so starting with 31, find the zeros of the quadratic function, and then write the function in factored form. Okay, no doubt these problems are going to involve I in the solution. Okay, so let's see what's going to happen here. Okay, 31. X squared plus 4 equals 0. Right? This is a quadratic equation. You can use the quadratic formula. And this is second degree. Therefore, how many roots are we supposed to get? How many solutions? Supposed to get 2. If we allow for multiplicity, meaning they might both be the same thing. But it's second degree, there's got to be 2 solutions. Okay, the fastest way I think to do this is to subtract 4. X squared equals -4. Do the square root property. Square root, plus or minus. X is plus or minus. All right, square root of -4. The negative comes outside, becomes an I. I root 4. Square root of 4 is 2. So plus or minus 2i. So my solutions are -2i and positive 2i. How do I write it in factored form? Don't let the fact that you have an I here throw you off. I mean, if it said a solution is x equals 7, that means x minus 7 is a factor, right? Okay, so x equals 7 is a 0. That tells me x minus 7 is a factor, right? Little timeout here, sidebar. So if you start here, right? You have x minus 7, blah, 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 blah. That means x equals 7 is a 0. But you can go the other way too. If you're building the polynomial, you start off with x equals 7 is a 0. That means x minus 7 is a factor. I'll do the same thing here. If -2i is a solution, then x minus that, x minus a minus 2i is a factor. And likewise, x minus 2i is the other factor. So this is the completely factored polynomial. It's not nice. Nobody said it had to be nice, but it might come out to be complex. Again, not the normal English definition of complex, but the mathematics definition of complex, the a plus bi stuff. So you'd say factor this. By the way, remember back in Algebra 1, you said, oh, you can't factor that. That's true, you can't factor it as far as the reals are concerned, but if you allow for complex numbers, this will always be factorable. And there it is, x plus 2i, x minus 2i. Non-real, but factors nonetheless. Okay, so if you allow for this complex solutions, if you have a third degree polynomial, it's going to be 3 roots and 3 factors. If you have 7th degree, there's going to be 7 zeros and 7 factors, but they're not all necessarily going to be real. You might have to do this I stuff, the complex numbers. Okay. Oops. 35. F of x equals 2x squared minus x plus 2. Find the zeros, so set it equal to 0. $35. Well, it looks tailor-made for the quadratic formula, right? All set to go. A is 2, B is -1, C is 2. So x is negative b, positive 1, plus or minus the square root of b squared, -1 squared is 1, minus 4ac, 4 times 2 times 2, all over 2a, 2 times 2. If you wish, you're allowed to put the quadratic formula on your cheat sheet. Let's see, this is 1 minus 16, which is -15. So you know you're going to have an I stuff. Right, 1 plus or minus the square root of -15 divided by 4. Take out the I. So 1 plus or minus I radical 15 over 4 are my two solutions. So we already knew ahead of time, it's, second degree. There will be two solutions. They don't have to be nice. They don't even have to be real numbers. They can be complex, meaning the I stuff, but here we are. All right, so my zeros are 1/4 plus or minus I radical 15 over 4. So x is 1/4 minus radical 15 over 4 I, and 1/4 plus radical 15 over 4 I. How do I write the factorization? Okay, same concept. If x equals 7 is a 0, you go x minus 7. So if a 0 is this mess, I go x minus this mess. X minus parentheses 1/4 minus radical 15 over 4i. And likewise, this will be x minus parentheses 1/4 plus radical 15 over 4i. It's kind of hard to say all that, but it follows the same principle, right? Whether it's easy, x equals 7 is a 0, x minus 7 is a factor. Or complicated. Okay. So this mess is a 0. So a factor is x minus parentheses, all that stuff. So here we go. That's how bad it looks. Okay. Okay, 37. Find all solutions of the equation. All right. X to the 4th minus 4 equals 0. Okay. So from the fundamental theorem of algebra that we talked about, what is the fundamental theorem of algebra? If you have a 4th degree equation, there should be how many solutions? 4. There should be how many factors? 4. 7th degree equation, 7 zeros, 7 factors, if you allow for multiplicity also. All right, so first I wrote this as a difference of squares. X to the 4th is x squared squared, right? And that's 2 squared. So I'm going to go x squared plus 2, x squared minus 2 equals 0. By the 0 factor property, that means either this is 0 or this is 0. X squared plus 2 equals 0, or x squared minus 2 equals 0. Move the 2 over, x squared equals -2. Move the 2 over, x squared equals 2. Square root, plus or minus. X is plus or minus I radical 2, or x is plus or minus radical 2. 4 solutions. We knew from the start that there's supposed to be 4 solutions. So plus or minus I radical 2, plus or minus radical 2. That means there should be 4 factors also. How do I write the factors? You just go x minus each of these. Okay, so here we go. X minus I radical 2. x minus a minus I radical 2, which means plus I radical 2. X minus radical 2, x minus a minus radical 2, x plus radical 2. All right, so from the start, I knew there was going to be 4 factors and 4 zeros. Here are the 4 zeros. Here are the 4 factors. Nobody said they had to be nice. They're definitely not nice. They've got i's and square roots and weird stuff like that. But there has to be 4 factors. Here they are. That, and that. Okay. And yes, if you felt like it, you could multiply this all out, see if you don't get this back. It should work. Okay. 41. X cubed plus 8 equals 0. How many zeros should there be? 3. How many factors should there be? 3. All right, one you can kind of tell right away is -2. Well, if you can't figure that out right away, do the algebra. Subtract 8. Take the q root, right? Q root, x equals -2. Double check, -2. -2 cubed is -8. -8 plus 8 is 0. Okay, I'll divide out the x plus 2 using synthetic division. That means I should get no remainder. And then I'll depress the 3rd degree to a 2nd degree. Once I get 2nd degree, I can use the quadratic formula. Okay, x cubed plus 8. Remember, that's x cubed plus 0x squared plus 0x plus 8, right? So any terms missing, count it with a coefficient of 0. So once you start with x cubed, right, you got to have an x squared and an x and a number. And if they're not there, count them as 0 coefficient. So notice 1, 0, 0, 8, which means 1x cubed, no x squared, no x, and 8 ones. And -2. All right, then I do my add, multiply, add stuff. Okay, 1 comes straight down. Multiply, -2 times 1 is -2. Add, -2. Multiply, -2 times -2 is 4. Add, 0 plus 4 is 4. Multiply, -2 times 4 is -8. Add 0. Perfect. And that's the way I'd want it. So when you're doing these problems, right, if you end up with something that isn't 0, then there must be a mistake somewhere. If this is going to be a factor and -2 is a 0, okay, there needs to be a 0 here. So if there isn't, then there's probably a mistake somewhere. All right, so my original polynomial x cubed plus 8 p of x has 1 factor. Careful, it's not x minus 2, it's x plus 2. Right, the game you got to play is, what number do I plug in to give me 0, -2? Change the sign. Okay, and the 3rd degree now becomes a 2nd degree. What 2nd degree polynomial do I have behind my finger? Read it off here. X squared minus 2x plus 4. Right? That's how it works. Right, so I know -2 is a 0, which means x plus 2 is a factor. And now how do I get the other factors? Well, I have this thing, which means I can go straight to quadratic formula. So x squared minus 2x plus 4 equals 0. Looks like a is 1, b is -2, and c is 4. So x is equal to, by formula, -b, +2, plus or minus the square root of b squared, -2 squared is 4, minus 4 times a, which is 1, times c, which is 4, all over 2 times a, 2 times 1. Okay, this comes into be 4 minus 16, which is negative. 2 plus or minus the square root of -12, all over 2. Now it's just some cleanup. Take out the I, right? Square root of a negative. 2 plus or minus I root 12 over 2. 12 is 4 times 3. 4 comes outside and changes to a 2. So 2 plus or minus 2i radical 3 all over 2. And you can cancel all the 2's. So that becomes a 1, that becomes a 1. So 1 plus or minus I radical 3 is what I want. All right, so the original was, where'd it go? Yeah, this one, right? X cubed plus 8. So there's supposed to be 3 zeros, because it's third degree, and 3 factors. Okay, so I found the 3 zeros, only one of which is real, -2, and 1 plus or minus I radical 3. Or you can say 1 plus or minus radical 3i. What are the factors? You just go x minus each of these. So x minus a -2, x plus 2. X minus parentheses 1 minus I radical 3. And then x minus parentheses 1 plus I radical 3. And yeah, you could work this out if you wanted to, but I don't think you want to. So you just leave it like that. Okay, so problems at the end. Given that the value of x is a solution of the equation, find all solutions. Okay. So let me show you some of this. So page 182. I've already talked a little bit about this without writing it or anything. The fundamental theorem of algebra. So what does all of this say? If you have an nth degree polynomial, you've got n factors, and you have n zeros, if you allow for multiplicity. So 7th degree, 7 zeros, 7 factors. 5th degree, 5 zeros, 5 factors, and so on. Okay, page 183, the conjugate pairs rule. So if you want to put this on your cheat sheet, you may. Suppose the coefficients of a polynomial are all real numbers. Z is a complex 0 with multiplicity m. Then its complex conjugate, Z with a bar on top, is also 0 of P with multiplicity m. Okay. Fast way of saying this is that if you have a complex solution, its conjugate is also solution. And that kind of makes sense if you think of what we did with the quadratic formula, right? Quadratic formula. Anytime you had 2 plus I blah, 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 you also had 2 minus I blah, 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 right? Very natural result because of the quadratic formula, right? So if you ever get one complex solution, maybe it came from a plus, then you automatically have the minus because of the way the quadratic formula works, right? And vice versa. Right, so once you're given one complex solution, its complex conjugate is also a complex solution. Okay. So, first example, 45.
That was saying though, like if there is a so if there is like if a plus bi to the degree of 3 then a minus bi to the degree of 3 is also a solution, right?
Correct. Okay. So that was formally the theorem, but in actuality, you're normally not going to get anything that high because it just gets too big. All right. But yes. Okay. So if you have 3 minus 4i multiplicity 2, you automatically have 3 plus 4i multiplicity 2. And it's as a result of the quadratic formula. Okay. Find all the solutions. All right. They already give me x equals I. That means automatically x equals negative I is a solution. How can I find all the solutions after that? It's not that bad because once I have x minus I and x plus I, that's 2 factors. That'll bring 4th degree down to 2nd degree. And once I have 2nd degree, I can always do quadratic formula. Is that right? So that's what I'm going to do.
For all of these for our answers on our homework, do you want them all to be written out in in parentheses, you know, mean like x minus I, x times x plus I times x plus 1 times x minus 3? Is that like how you want it to be written in the homework?
Correct. So
Okay.
you should write it out. Well, I'll show you. I'm about to do this one, so you'll see how I want it. All right, so x equals I is a root, 0 solution. Automatically x minus I is a root. Now, I could do synthetic division on I, but I'd rather not. It's a little bit clumsy, right? I don't want to do I's. I like real stuff. So that means I know x plus I is a factor. I know x minus I is automatically a factor also. Let me just multiply this out. What's x plus I, x minus I? X squared minus I squared. That's x squared minus a minus 1, or x squared plus 1. Now, I cannot do synthetic division on this because it's second degree. Synthetic division only works on first degree, but I'll do the long division, which hopefully is not that bad. So from the original, I will divide out x squared plus 1, like so. So x to the fourth minus blah, 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 divide by x squared plus 1. I should get no remainder. Let's try it. How do you go from here to here? X squared. Now, what's x squared times all this? X to the fourth plus 0x cubed. There's no x cubed. Plus x squared. Subtract. Nothing. -2 minus nothing is still -2x cubed. Got to be careful here. -2x squared minus x squared is -3x squared. Bring in a -2x. First thing here, first thing here. How do I go from x squared to -2x cubed? -2x. Now, what is -2x times this whole thing? -2x cubed plus no x squared minus 2x. Subtract. That minus that cancels out. That minus that cancels out. -3 minus nothing is -3. So -3x squared plus 0x, bring down to -3, and do it again. Finally, how do I go from x squared to a -3x squared? -3. Now, -3 times this whole thing, -3x squared minus 3, which I'm going to write as -3x squared plus 0x minus 3, and there it is. Anything minus itself is 0, so no remainder. So I have that. So my original polynomial is now x squared plus 1 times x squared minus 2x minus 3. By the way, if you have the time and energy, multiply this all back out, you should get this. There's the x to the fourth right there, right? X squared times x squared, x to the fourth. And then clean up all the rest of it, and you should get all this other stuff. And there we go. And now I could use a quadratic formula, but I notice this is pretty factorable. So x plus 1, x minus 3. And I already know what to do with x squared plus 1. All right. So my zeros, they already told me one of them was I. Where'd it go? Here. So right here, the 4 tells me 4 zeros. Here they are. I, negative I can write plus or minus I, -1 and 3. Factored form, x plus I, x minus I, x plus 1, x minus 3. So again, 2 of these don't come out nice. They're this complex stuff. But be that as it may, that's the way it is sometimes. You can't do anything about it. Okay, so 4th degree, 4 factors. Here they are. 4 zeros or 4 solutions. Here they are. So that is that. All right, folks, that was all I was going to cover today. All right, so I can finish this up tomorrow. So time-wise, we're good. We're just about finished with section, which means we're just about done with the chapter. Why don't I just mark it off? Okay, so I'll do some more from 3.6, but I'll start reviewing some questions from previous sections and some questions that people had earlier from some of these earlier sections in preparation for the test on Friday. Where are we? Yeah, over here. Okay. All right, I'm done, folks. Let me check the chat to see if anybody has a question because I can't see the chat. I'll share the screen. Okay, I don't see anything in the chat right now. Okay, anybody have a question? Otherwise, we're done for the day, folks. All right, that'll do it, folks. So have a good day, and we'll see you next time.
Thank
Okay,
you.
all right, bye, everybody. Thank you.